Have you ever stopped to really think about why we have seasons? I mean, it seems like a pretty simple question, right? But the answer most of us jump to, well, it's actually wrong. Today, we're going to dig into the real reason. And trust me, it's way more interesting. So go on, ask yourself, what's the first thing that pops into your head when you think about the difference between a boiling hot summer day and a bone-chilling winter night? If you thought something like, well, the Earth must get closer to the sun in the summer, you are definitely not alone. That is the most common idea, and you know what? It makes a lot of sense, at least on the surface. But that perfectly logical sounding answer, it's just not true. The real reason is so much cooler, and it all has to do with our planet having a permanent cosmic lean. Okay, so to really get a handle on this cosmic lean, we first need to quickly cover Earth's two most basic moves in space. These are kind of the building blocks for everything else.
So first, you've got rotation. That's Earth spinning like a top, which takes 24 hours and gives us day and night. Simple enough. Then there's revolution. That's our planet's big, year-long trip around the sun. But even knowing those two things, we're still missing the most important piece of the puzzle.
And that missing piece? Well, that's the secret ingredient. This is the one thing that takes a simple orbit and turns it into the cycle of seasons that we all know. And here it is. This is the magic number, 23.5 degrees. This number right here is the key to absolutely everything. So what is it? That number is Earth's axial tilt. Just imagine there's a giant pole sticking right through the planet from the North Pole to the South Pole. Well, that pole isn't standing up straight. It's tilted, or leaning over, by 23.5 degrees. And here's the most important part. That tilt always points in the exact same direction in space as we make our journey around the sun. Okay, so how can a simple, constant tilt cause such huge changes in temperature? Well, it all comes down to the angle of the sunlight hitting the ground. Let's make this super easy. Think of all the energy from the sun as a beam from a flashlight. The amount of light and energy in that beam is always the same. Now, if you shine that flashlight straight down on a table, you get a small, bright, really intense circle of light, right? That's direct sunlight. All that energy is focused on a small spot, so it gets hot. But if you angle the flashlight, that same beam of light gets spread out over a much bigger area. It's weaker, more diffuse. That's indirect sunlight. And that simple difference is the entire engine that drives the seasons. So when your half of the planet, your hemisphere, is tilted toward the sun, you get blasted with that direct, concentrated flashlight beam. The days are also longer, which gives the sun even more time to heat everything up. And the result? You get summer. Okay, now let's fast forward 6 months. The Earth is on the other side of the sun, but that tilt is still pointing in the same direction. So now that same hemisphere is tilted away from the sun. The sunlight hits you at an angle, its energy is all spread out, and the days are shorter. And the result, of course, is winter. So what about spring and fall? Well, those are the in-between seasons. During those times, which we call the equinoxes, neither hemisphere is really tilted toward or away from the sun. The sunlight is spread more evenly, and that's why we get those mild, comfortable temperatures. But hey, if you're still a little skeptical, if there's a little voice in your head saying, but the distance has to matter a little bit, right? Let's look at the final proof that just busts that whole distance myth wide open. So what's the one killer fact, the smoking gun, that proves without a doubt that our distance from the sun is not the reason for the seasons? Get ready for this. Our planet's orbit isn't a perfect circle, it's a little bit of an oval, so our distance does change. But here's the thing. Earth reaches its closest point to the sun in early January. And what season is it in the northern hemisphere in January? It's winter. We are literally closest to the sun when millions and millions of us are in the coldest part of the entire year. I mean, that fact alone proves it's not about distance. So, if you remember just one thing from all this, make it this. The crucial point is, it's the tilt, not the distance. Period. That is the fundamental truth of why our planet has seasons. All right, so let's put it all together one last time. What's the simple recipe that gives us our amazing tilted world? It's really just a simple 3-step recipe. Step 1, start with the Earth's constant 23.5 degree tilt. Step 2, add in our planet's year-long orbit around the sun. And step 3, that combination means that as we travel, the angle of that sunlight is constantly changing for different parts of the world, giving us the beautiful rhythm of the seasons.
And that kind of leaves us with one final cool thought to chew on. What would life even be like on a planet with no tilt at all? Imagine a world with no seasons. What would change? It's pretty interesting to think about. Thanks for joining me for this one.